Om Namah Shivaya. In this video, we will be discussing about parallelograms and how to find its area. A parallelogram is a quadrilateral. Before knowing what a parallelogram is, let us find out what a quadrilateral is. A quadrilateral is a polygon which is made out of 4 line segments. That is, it consists of 4 sides. Besides sides, it also consists of 4 vertices, 4 angles and 2 diagonals. So, as we discussed before, a parallelogram is a quadrilateral. As the name suggests, it has something to do with parallel lines. Actually, a parallelogram is a quadrilateral with each pair of opposite sides parallel. A parallelogram holds a number of properties such as the opposite sides of a parallelogram are equal, the opposite angles of a parallelogram are equal, the adjacent angles of a parallelogram are supplementary, and the diagonals bisect one another. Now, we will discuss about how to find the area of a parallelogram. But before finding out the area of a parallelogram, we have to know and understand 2 important terms. These important terms are base and height. What are base and height? The side of the parallelogram which we consider can be taken as base. Any side of the parallelogram can be taken as base. And the perpendicular distance or the perpendicular line segment from the opposite vertex to the side or the base which we have taken is called height of parallelogram. So, to find the area of a parallelogram, we have to know its base and its height. We know that to find the area of a rectangle, we have just multiplied length and breadth. That is, the area of a rectangle is equal to length into breadth, L into B. We also know that a rectangle is a parallelogram with equal angles. That is, all the angles of the parallelogram with 90 degree becomes a rectangle. So, let us try to find the area of a parallelogram with the help of the area of a rectangle. Let us consider a parallelogram ABDC. We put a point E in between C and D in such a way that point E is closer to point C, and also we can get a straight line by connecting points A and E. Now, from the parallelogram ABDC, we get a triangle, and that is a right angle triangle AEC. Now, just imagine that we are cutting this right angle triangle AEC from this portion and taking it to the other side of the parallelogram, which is near line segment BD. We can observe that this right angle triangle can correctly fit at that portion, and also we observe that the parallelogram which we have created had now become a rectangle. So actually, the area of a rectangle is somewhat similar to the area of a parallelogram. Here, for parallelogram ABDC, the base was CD and the height to it was AE. Notice that we can take any base and its corresponding height. In this case, we have taken the base CD and the height corresponding to it is AE. When the parallelogram transformed into a rectangle, the height of the parallelogram gets changed into the breadth or the width of the rectangle. The portion CE of the right angled triangle AEC, when taken to the other side, get joined with the other portion of the base ED to form a full length of the rectangle. So we can say that the base of the parallelogram gets changed into the length of the rectangle, and the height of the parallelogram gets changed into the breadth of the rectangle. Since area of a rectangle is equal to length into breadth, therefore the area of a parallelogram is equal to base into height. Now let us look at an example. For example, consider a parallelogram PQRS. The measure of the base QR is 8 centimeter and its corresponding height measures 6 centimeter. So what is the area of this parallelogram? We know that the area of a parallelogram is equal to base into height. Here the measure of the base is equal to 8 centimeter and its height measures 6 centimeter. So the area of this parallelogram PQRS is equal to base into height, that is 8 centimeter into 6 centimeter is equal to 48 centimeter squared. Likewise, we can also find the area of other parallelograms as well. I hope you understood how to find the area of a parallelogram by watching this video. Thank you. Nam Shivaya.